Good morning. It is so good to be back in Poland. It's been a long time. If the speech doesn't go well, you can blame Pavel Bartosz, wherever Pavel is, his fault. Okay? So who likes technology? Yeah? Okay, that's supposed to be an easy one. There's a group over there. I'm not sure. I'm assuming if you're here, you like technology. Who likes science fiction? Yeah? So one of my favorite science fiction authors, and I'm not just saying this because I'm here, is Stanislaw Lem. And he's not very well known in Western Europe, the UK, etc. So a lot of people aren't familiar with him. But I would like to use some of the stories that Stanislaw Lem tells as some metaphors for how we build. So we've got 2 days where we're talking about the most incredible technology, the incredible things that you all are building. And Stanislaw Lem has, through some of his stories, particularly the Siberiad, he's got some great advice, almost some anti-patterns, for what happens when we use technology without reason, when we use technology without a thought to people. And the big topics that I would like to cover over the next 40 minutes is how we construct, how we improve the teams that do the constructing, that's all you guys, and how we drive the transformation in the companies that we're all in. What do you think? Sound good? Yeah? Now would be the time to leave. Okay. Okay, so I think that the science fiction stories of Lem are actually very sad. They're sad because what you find is there are about 2 robots, and their names are Troll and Clapertius. Who's read some of these stories? Anyone? Come on, come on. You should be ashamed of yourselves if you haven't read. Okay. So they're about these 2 robots, and maybe 50,000 years in the future. And they build whatever they want, with no thought for resource, no thought for constraints. And in the stories, there's no real sense of time. Doesn't that sound awesome? You don't have to worry about resources. You don't have to worry about time, right? Just build whatever you want. And of course, there are some downsides to this. And this is particularly what I'm going to talk about. And that's why I think that some of these stories are actually quite sad. But they offer great advice for us. So the first thing that I'd like to talk about is, what kind of a constructor are you? Are you a being who creates what it wants with little reason and constraint? I just build stuff because I want to. Or are you somebody who creates value for others with limited control of resources? Which do you think's better? Which would you like to do? Who votes for the first one? Come on, be brave. Who wants? Yeah, there's a brave dude over there. Come on, screw resources. Okay, fine. Who has a sense of why they're building? Yeah? Is that just one lonely dude? I understand why I'm being asked to write this code, right? Everyone else thinking, I don't know, I just got given a thing to write and I'm just writing it. Leave me alone. So what I'd like to do is I'd like to tell the first little story. So Troll, who's one of the robots, he's always in competition with Clapertius. And he decides to build a robot that can build anything beginning with the letter N. Yeah? Not O, not P, not Q, anything beginning with the letter N. It sounds a little bit like some of the business requirements you've maybe had in the past, right? Build something beginning with the letter N. That's enough. Get on with it. When's it? Why isn't it ready? So this robot can build anything beginning with the letter N. And so he tests it. And it starts building noodles and negligees and naphtha and all sorts of things. And finally he thinks, okay, this is ready. I'm ready to show Clapertius. So he invites Clapertius over. Clapertius has a look at it. And Clapertius asks it to do nothing. And of course, it just stands there for a while. And he says, you see, it's not working. But then, of course, what happens is the robot is actually doing nothing. And so slowly, things start disappearing out of the universe. All sorts of things, not just things beginning with N, but nothing begins with N. So a whole bunch of things start disappearing out of the universe until finally, what he has to say is stop. But unfortunately, at that point, the damage is done. And so for all of the future stories, the world that these guys live in, the world of these robots, is honeycombed with little areas where there's nothing, where there used to be something, and this machine has just taken it away. Now, they try to repair it, but it turns out you can only make a robot that's able to build things starting with the letter N. Okay? It's not possible to build a robot starting with the letter O. So what's the metaphor? What's the moral from this? Well, there's two really interesting things, I think, here. One is trying to anticipate unintended consequences, trying to anticipate the complexity of tasks. Who's a big fan of estimation? Who estimates? Come on, you love the Fibonacci series. Yeah? Who does planning poker? It's okay. It's a safe place. Okay, brave dude over there. He's looking a little stressed. That's what happens when you use Fibonacci to plan. But the fundamental problem that we have when we are estimating the consequences of things, whether they are relatively small projects or relatively large projects, is we make a ton of assumptions. And in making those assumptions, what we tend to do is we tend to act to make them real. And so as we are managing the project going forward, the things that we're looking for are essentially ways of validating the assumptions that we made when we made the estimates, right? And so there's a growing movement called the no estimates movement. And the no estimates movement is based on the idea of, well, if you can create small enough sprints, small enough packages of work, you can get people around a table, the doers, you all, and you can say, can you do this in 2 weeks? People go, yeah, I think we can probably do this in 2 weeks. But the challenge you may give me is, well, okay, but what about bigger tasks? What about 3 months? Who's ever done a 3-month estimation that's been accurate, even close? With Fibonacci series or anything else for that matter. It's an illusion, right? So what has this got to do with Trill? And what's this got to do with the robots? Well, it turns out that the reason why estimating small pieces of work without pretending to have science only works if you add another factor to it, and that's velocity. So this is, of course, one of the things that these robots in the stanislaw of Lem world are able to do. They're able to build these things incredibly fast, incredibly successful, right? Now, velocity is something that is fundamentally changing how and what we construct. Let me give you an example. So who's bought a car recently? Anyone bought a car recently? Yeah? The A6. Who owns the A6? Okay. Did you buy it? Or was it leased? So someone over there bought a car recently. So when you buy a car, how do you choose the car? You choose a car based on features, right? So, number of doors, number of wheels, I guess. Upholstery. It's Poland, so you probably want the seats that warm your ass in the winter. These are features, right? These are features. This is how you choose a product, right? That sounds fair. But there's a problem, and that is because of the cost of purchasing a new car, you have to live with your decision for a while, right? No one buys a car, drives it off the lot, and then thinks, I'm bored now, turns around and goes back, and then sells it for half the price you paid for it, right? So you have to live with that decision to purchase those features for a certain period of time. What happens if we relax that assumption? What happens if we relax the assumption that you don't have to live with the choices that you're making about features? So who's heard of Zipcar? Anyone? Zipcar? Silverline? So these are models where if you want a car, you go to the app, and you say, well, I'm here. And it says, okay, well, the nearest car to you is parked around the corner. You go up to the car, you wave your phone at the car, it opens, you drive, you get out, you abandon it somewhere, right? You lock it, and you walk away. And it charges you for the amount of time that you've used that car. Now, in that model, and by the way, the Dutch have been doing this for maybe about 15 years in different formats, but it's beginning to catch on in the US quite strongly. Now, in that model, how much do you care about the features of the car? I mean, I understand. The ass warmers, absolutely non-negotiable. But apart from that, how much do you care about the features of the car? Do you care about the color? Is it like a big deal? Probably not. Do you care about the upholstery, and is it all nice and soft? Probably not. You're only using it for a couple of hours, right? So what tends to happen is as you start to think about some of these physical assets that are out there, that customers, our customers, are using software to access, what's happening is the actual differentiation of those physical assets is reducing in terms of features. And what's beginning to be important is not so much the features, but how fast you can get rid of it. Is that incredible? So the big issue here is you want a car so that you can access the service so that you can get rid of it and stop using it. So how does that apply to software? How does that apply to the software that you guys are all building? So who likes task management applications? Anyone like task management applications? Come on, seriously. Yeah? Thank you. Are you a manager? As a manager, my staff love my task management applications because I change the task management application every week. It's very convenient for them. So I love task management applications. This is God's honest truth. You can ask the people who know me well. And any task management application out there on the Apple Store, because I happen to use the iPhone, I will download and try. It costs 99 cents. So the barrier to me downloading this thing is very low, right? It's not a big deal. There's not a lot of friction. So I download this 99 cents app and I have a look at it and I start to kind of play around with it. Using the metaphor or the example of the car, how do I choose a task management application that I continue to use? Because remember, I've bought it, gotten $1, paid $1, so it didn't cost me a lot, low risk, doesn't mean I'm going to continue using it. What do you think makes me continue using that task application? This is a test. Someone's handing out the papers, come on. Okay, yeah, so what about the data? The funny thing is that would I sit down like this dude over here, you and I, we're the same kind of guy, I can tell, right? Got 100 tasks written down in a little application, priorities, dates, everything. We ignore them, but they're there, okay? It's in data form. So I don't want to have to rewrite all of that data, right? I don't want to have to do it again. So what's important about this new task application that I download? That it can import that data, right? Now, once it's imported that data and I've used that application for a little while, what's important? It's important that I can get the data out again, correct? Now, beyond a certain threshold of basic things, like this application can do tasks and has dates and things like that, what's most important? What has become most important in my evaluation of the task app? That I can move away from it. Isn't that an incredible thing? What does that mean for your software that you're writing? What does it mean for software that we're all involved in, where one of the critical features of that software has to be to enable customers to move away, to try something else? Because so important is their core assumption that there will always be something coming up that's better. Our customers are not wanting to commit to one product for a long period of time ever again. Are you making software that can live in that world? Now, you may think that this is a very, very difficult model to monetize, but you find in the Apple Store that you monetize that through additional features and things like that. Where did we first find this particular idea of being able to frictionlessly move between platforms? It's from the open source community, right? And so we're beginning to see these core behaviors, these core values that shape this community here, beginning to shape the economy as a whole. Now, it turns out that the only way that it's possible for a software company to succeed is in order to continue making faster and faster feature updates. Because the assumption has to be people will go, but they'll come back. In an environment where you can look for information about the features that are now available very, very easily, very, very low barriers to information flow, people are always finding out about the new features. So you have lots of opportunities to come back. But what if you're one of those companies that deploys software like every 3 months, quarterly? Put up your hand. Put up your hand. Someone will hug you. But if you're one of those companies, what do you do? Now, you may think that this is not a reality for the big corporates like banking, etc. But you've heard the phrase, right? The Uber for banking, right? Now, I don't know what it is, but I can promise you one thing, that the only way that us as software engineers are able to help grow the value of the companies that we're working in is to fundamentally obsess about velocity. There's nothing else that matters. Because to go back to the Troll and Klaposch's example with the robot that makes things with the letter N, all you're able to do is you're able to put something out there, get a response. It only took you a certain period of time. You didn't have to estimate a whole ton. You got it more or less right. You get feedback from the customer. You then do another sprint in another 2 weeks, then do another sprint in another 2 weeks. You're continually getting feedback. But the value that you're generating is based upon the fact that what you are building is finely tuned to the feedback that you're getting in the market. And you're only able to get fine-tuned feedback in the market if you're able to operate at velocity. So the first key message that I want to leave you with when we talk about construction, what it means to be a constructor, is velocity. This is the one maybe positive idea that we get from the tales of these robots, right? They're able to build anything incredibly fast. But what's really, really important for you all to focus on is this idea of creating software, refining that software at the highest velocity possible. So the question you have to ask when you go back to work after this conference is, what barriers are getting in the way of me just getting stuff to production, getting stuff in front of customers? If it's not in front of customers, it's a science experiment. It's waste. So what can we all do to remove obstacles in our organization, things that slow down or add friction to delivering software, getting it out into production? Okay, so let's answer that question. What can we do? So there's this next story. So Troll and Klaposch, kind of crazy guys. Troll decides that he's going to play a trick on Klaposch. So he sends Klaposch a robot. The robot knocks on his door and he says, "Hi, I'm here from Troll the Magnificent." And of course, immediately, Klaposch is going, yeah, magnificent, sure. Robot comes in and he says, "I'm here to grant your wishes." So Klaposch says, "Okay, we'll sit down." So the robot sits down, waits, and Klaposch is making something. And the robot says, "Can I help?" He says, "Yeah, I need a number 5 screw, I need one of these things, I need one of these things." And the robot just produces them. Klaposch, if you read the stories, he's very difficult to impress. So he says, "Fine. What will impress me is I'd like you to make me a troll. Make me Troll." And so after a little while, Troll gets out of this robot. He says, "Here I am." Wow, how did I get here? and it looks and feels, it's exactly like Troll. So what does Clopercius do? He beats the living hell out of it, right? Just because he can. So after a while, he stops. He's getting kind of tired from beating it into that kind of shape. And he thinks, I'm going to have a rest. So Troll takes this opportunity to escape. So Troll escapes. The next day, what happens is, Clopercius then goes to visit Troll. Now it becomes obvious that it was Troll. And all Troll was trying to do is he was trying to spy on Clopercius. Trying to use the robot to get into Clopercius' study and see what Clopercius was working on. Now, the little twist in this story's tale was, you know what Clopercius was working on, that the robot was helping him with the number 5 screw, etc.? It was the exact same idea. So that's a little twist in the tale. What's the moral? Wow, in this particular world, there are no new ideas. That's an incredibly sad kind of position to be in. So let me ask you this question. How many of you are working in teams where the technology that you are using is continually improving? Where the knowledge that you may have of the technology that you're using is continually improving, but the efficiency and the effectiveness of the team that you're working in isn't? The code may have changed, maybe the language has changed, maybe some new frameworks are there, but are you, as a team, as an organization, are you working better together? Someone who's worked in a very large organization before, one thing that is clear is there are some people in those organizations that have essentially been doing the same job for 10 years. So it's 1 year's experience 10 times. Now, if you take that view, is it possible to generate high-velocity software? Is it possible to be generating new value for customers every 2 weeks? Is it possible to do it? What do you think? Yeah? What do you think? Yes? No? Someone's shaking their... No. Thank you for that. $5 later. So, it probably isn't. Why? Well, because the reality is that in order for us to be continually improving our product, doesn't it follow that we have to be continually improving ourselves? Doesn't it follow that we have to be continually improving the teams that we have? So how many of you, just as an example, and this is a very obvious one with DevOps, how many of you, as an example, work closely, if you're a developer, who's developers in the room? Hands up. So developers and infrastructure people, yeah? So do you guys work closely together? How many of you working absolutely in the same team as your infrastructure development people? Yeah? How many of you aren't? Right? So if you aren't, part of what DevOps talks about a bunch of other things, and we'll hear about it over the next 2 days, but part of what DevOps is talking about is breaking down the barriers, not just so that we can all hug and be a bunch of hippies, but because fundamentally your ability to be able to learn and your ability to be able to create better value is improved by virtue of having teams that work together on a common outcome, on a common thing, that value to the customer. So what if one of your objectives going forward was to work out how you could do that? Was to work out how in the next project or in the next sprint, you could have the infrastructure guys sitting next to you as you deploy. How many of you have to wait for requesting the provisioning of VMs and things like that? How many of you have that done by somebody else and you're kind of at their whim? Tell me, yeah? Honest dude down here. Well, that's a great example of improving team effectiveness, right? Other good examples. How many of you invest time in automated testing when you absolutely can't afford the time? How many of you have had conversations with Scrum Masters where it's, look, if we do some of these things, if we automate this test, or if we write some chef to automate some of the configuration perhaps, if we do these things, we'll be able to be more productive later. But we need to use a couple of hours or a day now to do it. And the answer is, stop thinking about that. Just write the code that you were asked to write. Write the functions you were asked to write. It's like the story of, these Canadian woodsmen. They're sawing down trees, Someone walks past, looks at all of the trees that they have to saw down, and he says, "Phew, wow, that's a lot of trees you have to saw down. How sharp is the saw?" And the guys say, "Shut up, we don't want to talk about how sharp the saw is, we're too busy sawing." Right? So how much time do we spend on creating that environment within our teams in order to improve ourselves so that we can have new ideas? Because sometimes, not always, but sometimes, it occurs to me that with the incredible talent we have in so many software teams that I work with, it almost seems that in some ways we are narrowed, we are shaped by ideas related to the technology that we're using itself. And we don't start looking at how we can use each other as a resource to become smarter and better, and how we can start better organizing our teams. So one of the basic ideas that we use in the practice that I run is this idea of the two-product principle. And I'd like you to give this two-product principle a thought. The principle is simple. You always ship twice. So let's imagine for a second, you buy what I'm saying about this high-velocity software development. You buy the fact that the only way to keep customers is to keep on giving them features to make them come back. Assume they will leave. Make new features that keeps them coming back. While you're doing that, you're trying to improve the team. Now let's imagine in that 2-week period, that 2-week sprint where you're deploying new features, what you're doing is you are building something. What if at the end, when you release the software, you release an increment of the software that your customer sees, but you also release an increment of the capability that your team is offering to the company that you work in? What if you saw your development efforts? What if you saw every 2-week piece of work as an opportunity to increment the capability of your team itself? It answers one very simple question. If I was a venture capital investor, and we find, I'm already beginning to see in banks in particular, funding beginning to change. People are beginning to think in a more appetite-based way of funding. No more of this bottom-up budgeting where you have to predict 57 years out what the costs are going to be and all the milestones. People are now thinking, okay, I'll invest in your project for 2 months. Why should they invest in your team? Literally, why should they invest in your team? Lots of people are now beginning to realize that software is eating the world. Lots of skills around Chef. It's one of the most in-demand skills in the world right now. Lots of skills around, you name it, Java, Ruby, Angular, whatever it happens to use. So why use you? And this is a fundamental idea that we have to start understanding. Not only does the idea of developing software at velocity create greater value in the hands of our customers because we're responding to them, what it also does is it puts pressure on us and an opportunity on us to request investment in our team. Because the conversation that you have with product owners, with product managers, with your managers, with scrum masters, etc., is we can continue to improve the software that you're asking us to improve. We can continue to improve and iterate this software, but you have to invest in the team that does it. Now, teams that have a track record for delivery, I've never once found a case where scrum masters and product owners are not willing to give it a try. The thing is, though, the two-product principle is a contract. It's a contract between those who control the resources, product owners, investors, etc., and the teams who are consuming the resources and creating a return on those resources by releasing software into production. It's a contract. You have to deliver in order for them to invest in you. But it's a very, very powerful idea, because what you don't want is you don't want to find yourselves in projects where you've been working on the same technology, even if it's been improving, for 5 years, and it turns out the team that has been making that software hasn't been getting better, hasn't been offering you opportunities to learn from each other. So please focus, give some thought to this idea of the two-product principle. One of the things that we get from these stories about these robots is they never focus on the improvement of themselves. They never focus on the improvement of the world or any reason to build. And this is one of the cautionary tales that Lem gives us. It's that what we need to be doing is we need to be building to add value to someone out there, but at the same time, and maybe this is the key idea, at the same time we're building to also build the capability of the team so that we can continue to build great stuff. Who wants to build great stuff? Yeah? Okay, so this is this idea of continuous improvement in the two-product principle. So the final story. Trill builds a robot, and he wants to test it. And so he asks, what's 2 plus 2? And the robot says 7. And so he goes in and digs inside the robot, and, it's a very cyberpunk robot. There's no code, apparently, in these robots. It's all pipes and screws, number 5 screws. Stanislaw Lem, big fan of the number 5 screw, for some reason. So he's digging inside, and he's trying to get it right. 2 plus 2, the robot keeps on saying 7. And so Clopertius and Trill, they then insult the robot. The robot gets really, really cross. The robot then chases them across town, finally barricades them inside a cave, and tries to force Trill to admit that 2 plus 2 is 7. Of course, finally Trill just freaks out and says, no ways, there's just no ways 2 plus 2 is 4. And then in a chance encounter, a little rock falls from the mountain and squashes the robot. And it's funny because in the story what happens is Clopertius and Trill walk away without any further comment. It's as if they learned nothing from this event. So here's my question to you. What does the rest of your organization learn from your successes and your failures? Do you create events in your organization that the rest of your organization, the other teams that are in your organization, can look at, point to as areas that they can learn from? So something that's really powerful, and we use this when we're working with large enterprise customers. Pick something. Pick an organizational problem. Pick an organizational problem that everyone, if you ask them, everyone would say, no ways, it's impossible. Now for you guys, because you're all cool and you like work for cool software companies mostly, etc., this is going to sound really dumb, but in large enterprises, what I often have is I often have people coming to me and basically telling me, you know what? It's impossible for us to deploy a VM, or provision a VM rather. It's impossible for us to provision a VM in less than a month. Now for you, that may sound bonkers. Large enterprises may be heavily outsourced, etc. It's just impossible. What happens when a team, using some ideas from DevOps, having the infrastructure guys sitting next to them, what happens when a team is able to turn that wisdom, turn that assumption on its head? And all of a sudden, we now have a team that is essentially creating and destroying, provisioning VMs on demand as they go through their development process. What happens in the organization? It creates an event. It creates an event that everyone can point to and say, oh, okay, so stuff is possible. This thing that we thought was not possible is possible. Now, if we learn something from these very, very strange, slightly psychopathic robots, it's that there's a great deal of joy in making things possible in our organizations. Don't we want to make things possible for our customers? And we also want to make things possible and better for the people inside our organizations and our teams. Don't we want to do that? Or do we just want to be a bunch of guys just kind of sitting in a little bubble, don't care about anything else? Because the reality is if we operate that way, what will tend to happen is our organization will learn less fast than it needs to. And if our organization learns less fast than it needs to, it will get less revenue than it needs, get less investment than it needs, and we all lose. We all lose. So my question is this: when you go back to work, what organizational problems, technical problems, things that the organization thinks that can't be done, what can you solve? And what an incredible effect will you have by showing the organization that you're able to solve it, apart from being rock stars and being able to, stretch your stuff. The reality is that we begin to change how the organization talks about what's possible. We begin to change how the organization empowers teams to create great software. And if we create organizations that create great teams, that create great software, the cycle starts again. We create great software, and they need great teams, and so they invest in great teams. So what I'm saying is that there's definitely this relationship, this contract that we have with those who invest in us to create great value, and in return for the great value that we create, to request or demand investment in us, investment in you all, and invest in the teams that you're part of. So a nice way of summarizing this idea, and I have 18 seconds apparently, is this phrase. We team to release. Put a team together to release. Why? Because it's not just one person pushing a button. We want full stack teams. We want infrastructure people. We want operations people. We want security people. We want developers. We want a bunch of people. Can I stand on this? There we go. So we want a bunch of people. We want a team to release. So we team to release, but we release to learn. We don't just release software just so that, okay, we can go on to the next card, the next story item. We release software for the express purpose of getting feedback from those who use the software. We release to learn. That is the purpose of release. If it wasn't, well, we wouldn't need anything in production, would we? Because the science experiment was proven in test. We release to learn. But then we also learn to build better. As we learn, the feedback that we get from our customers and from the market, we learn to build better. And as we learn to build better, we build so that we can create great teams. Because the reality is, and this is the core idea that I want to leave you with, the reality is that without great teams that are deep and broad, that get better at sharing knowledge, it's extremely difficult to keep up the demands of high-velocity software development. We need to be continually investing ourselves, investing in our teams, so that we're able to operate at high velocity. And so while the technology that we're using is absolutely awesome, unfortunately, the technology on its own is not sufficient in and of itself to guarantee either our continued employment or the continued awesomeness of our software. What helps us do that is build great teams that can help us build great software. And in order to do that, we have to be focusing more than ever on how we learn together as a team and how we learn from our environment around us. And in order to do that, what's the number one thing? If anyone's getting a tattoo, apparently there are going to be tattoos later. Pavel said he's going to be the first one to get one. And the thing that he's tattooing is which word? Give me one word. Velocity, thank you. Thank you very much, everybody.